Hi, this is Mrs. Cribb, and I'm going to be going through the Chapter 3 review video. The first thing I've pulled up here is the Prezi for significant figures, and this is just not one we've gone through in class, but it does have resources on it that you can use. One of them is this Sig Fig practice site. You can click on it, and we did a lot of these in class, but there are 20 questions, and it would be good for you to go back and review these if you needed to do some more review. This is found in the Sig Fig Prezi, and I think it's also found in the Chapter 3 Prezi. The next thing we're going to do is just review significant figures. So, significant digits are the ones that you know for sure plus one estimated. So here I want you to see this estimation. Let me pull this up a little bit closer. So we're trying to figure out what this line would be, and there's two different rulers here to look at. This one only measures from 1 to 2 and 2 to 3, and let's say this is centimeters. So I would know for sure there's 2 centimeters. That's why there's a 2 right there. And then I'd have to estimate how far between the 2 and the 3 the next digit was. And this time we estimate the 5. So this would be the last significant digit by estimating one spot past what I know for sure. And what I know for sure are the lines. But up here we have more lines. So we actually know for sure 2, and we know point 1, 2, 3, 4, 5. So right here, 2.5 is for sure. Now I have to estimate between 0.5 and 0.6. And so it looks like it's halfway between them. So the 0.55, the second decimal place, is now the estimated place value. This instrument is more precise, goes down to a smaller place value than this instrument. So maybe that will help you with significant figures. Okay, we're going to go over this video for a minute. I may stop it occasionally.
Okay, so here is our measuring tool. We're going to use this as a standard to measure mass. So this measuring tool will tell me to the 10th of a gram. So obviously I have 0 grams here all the way up to 1. These lines in between represent a 10th of a gram. So this is 1.1, 0.2, 0.3. You get the idea. What I have to do is estimate between the 10th of a gram. Let me blow this up for you real quick. So in the space in between a 10th of a gram, I must then estimate. That's what I don't know for sure, but I must estimate that digit. So I'll break that into, let's say, 10 divisible marks and estimate how far it is. If I look over here where my slider is, I see that it's just past the 3.1. So I know for sure it's 3.1. Let me write that down. So I know for sure it's 3.1. That's what I know for sure. I must now estimate this last digit. I'm going to estimate that it's a little bit past that. It's 3.11. I'll put the units as grams. That gives me then 3 significant figures. 3 sig figs.
Okay, so now we've talked about this. Every non-zero number is significant, and then we've talked about the zeros between the non-zero numbers are significant, and we also talked about leading zeros are losers. So that's a losing number. So there's only 3 sig figs in this number right here. And now we're going to review the Atlantic Pacific rule. So here I wrote on this particular piece of paper my very weird Atlantic Pacific rule. Leading zeros are losers. And so here this number 56,700 grams. Remember that sig figs have to have a unit, a measured unit. So leading zeros would be losers. So this has 1, 2, 3, 4, 5. 5 sig figs in this particular number. Sig figs need a unit, and people and jelly beans are not units. Counting numbers have infinite significance, so you don't measure that. You don't look at those for sig figs. So 12 eggs, sig figs do not apply. Neither do 21 students. And definitions like 12 inches equals 1 foot when we're doing calculations, the significant figures do not apply because that's a conversion factor. It's not what we measured. We only have to look at measurements. So let's figure out the sig figs in these numbers. There's a decimal place. So we're going to come in from the Pacific. If I were to write this number on my United States, it'd be, oh, sorry, I wrote it incorrectly. Let me fix that real quick. if I were to write this number on the United States, it'd be 417.01. There is a decimal place. It is present. So I come in from the Pacific and I cruise along until I hit the first non-zero number, and then I count sig figs. Everything after that is significant. 1, 2, 3, 4, 5, because I have the decimal place. Okay? So here I have the decimal place. We come in from the Pacific. We count 1, 2, 3. 3 sig figs. It has a unit and a decimal point. Here I have a decimal point. Come in from the Pacific. The point is present. 1, 2, 3, 4. 4 sig figs. Here the decimal point is absent. Okay? So when the decimal point is absent, we're going to come in from the Atlantic. So let me write that number up here. That's 5,000. This time it's absent. We come in from the Atlantic. We keep going past the zeros, and the first non-zero number is the 5. And so this only has one significant figure. And this one, also the decimal, remember for scientific notation, you only look at this portion. You don't look at the 10 to the any power. You only look at this portion. It's absent. There's 1 sig fig. Here, it's present. We come in 1, 2 sig figs. 2 significant figures. So that's just a review, and we'll come across these as we're doing some of the problems in the video. Okay, now we're back at the Prezi, and I skipped over to the calculating portion. So when calculating, you need to determine the number of sig figs in the numbers used, but exact numbers and numbers that come from definitions will not matter. Okay? So addition and subtraction with sig figs. This is a video that talks about addition and subtraction with sig figs. We're going to go ahead and watch this one.
This video is going to show you how to add and subtract numbers according to the rules of significant figures. To begin with, I have a little problem that I've created. It's a sample calculation. First thing you want to do is do the math.
Okay, we are going to have to assume that all these numbers have units. That's the only thing wrong with this video. So this would have to be grams and grams and grams, or meters and centimeters and something. Meters and meters and meters. They all have to have the same unit. So assume all these numbers have units.
Calculation, keep all the decimals in every single step. You get an answer with a whole bunch of decimals. Now when we apply significant figures, we're going to figure out where to round this number. So if we're going to round it to the tens place, the ones place, or all the way down to the thousands place. So we're going to figure out where to round this number using the rules of significant figures after we've already done the calculation once. So the first thing I want to do is I'm going to take all the numbers and I'm going to line them up vertically when I'm adding or subtracting. So I've lined them all up vertically. Now what I'm going to do is figure out where the estimated number is in my significant figures. So I go through my rules of significant figures and I determine the 9 on the far right, the 5, and the 7 in the tenths place. Now your final calculation at 37.514 is only as good as your worst estimation. That is the number that is the largest. Or in other words, when it's lined up like this vertically, it's the estimated number that's farthest left, which in this case is the 7. Since the 7's the farthest left, I'm going to round my answer of 37.514 to the same place as that number that's farthest to the left. In this case, the tenths place. So the 37.514 is rounded to the tenths place, just like this 7, and that's going to give me 37.5. Let's take a look at a second example problem. So in this example problem, I'll do the same thing I did before and do the math, and just for the ease of calculation, I'm going to line it.
Okay, let's look at this one. Which one is the least significant? Remember, or sorry, the least precise. Remember, these all have to have units. This one is precise to the ones place. This one is precise to the tenths hundredths place. This one is also precise to the hundredths place, and this is precise to the thousandths place because this one has a decimal. So the ones place is the least precise spot. So when we get in the end of adding it all together, we should probably have to round to the ones place. So let's skip a little bit. There he added all the numbers up, and now we need to round to the ones place. He's showing you where all the precision ends. I'm trying to get to the answer. It's showing you the ones place is the least significant, the least precise. So it has to end in the ones place. Now, it doesn't have to have 1 sig fig. It has to end in the ones place. So we're going to round to the ones place. Let's listen now.
So when I round it, 18.5 becomes 18. kind of odd, but remember, we got those rules.
Okay, now that's where we're going to stop with this video. He does go into the exceptions for rounding with 0.5, and we are not going to be concerned with that for our purposes. Okay, so let's move forward. So here's another example. This one ends in the tenths, the hundredths, and the thousandths. We do the math. We have to end in the tenths because this is the least precise number. So we round our answer to the tenths place. The 9 is in the tenths place, so our answer must end. Notice there are 3 significant figures in this number, but there are only 2 here. Because when you're adding and subtracting, you don't count sig figs. You look at the place value, and it has to end in the same place value. And this is another way of doing it. You line them up. You're subtracting them. You see that this one ends in the tenths, hundredths, thousandths, 10,000ths place. This ends in the 100,000ths place. So we look at precision. Since it stops here, the answer has to stop there. It only has 3 significant figures because these zeros are leading, and leading zeros are losers. So 3 significant figures, but it ends in the same place value. All these 2 numbers had more significant figures, but we weren't concerned with the number of sig figs. When you add and subtract, you look at precision, place value. And that brings us to multiplying and dividing sig figs. We're not going to look at the video on this one. We're just going to look at a couple of problems. In fact, let me just scroll past the video. Okay, when you're looking at sig figs for multiplying and dividing, you count them. So this one has 4 sig figs. This one has 2. The answer can only have 2 sig figs, so we have to round it to get to 2 sig figs. That's not a 2 sig fig number, that's a 3. So here, multiply it. This one has 2 sig figs. Our answer has to have only 2. Multiplying and dividing, you do count them. Now assume again these have units, because with no units, sig figs do not matter. Okay, now we can look at these. We multiply these 2 numbers. Notice we got meters times meters to get meters squared. That's very important. When you type in your answer, you may have to put meters up caret 2. But 2 significant figures in this number, 3 in this number, our answer can only have 2. That means we have to round 1, 2. We round right there to get 23. Here we're dividing, and notice that grams divided by centimeters cubed, that's my unit. That's fine. I can't cancel out those units. That's a density unit. All right. Now, there's 4 sig figs in this number. There's a decimal point that's present. You come in from the Pacific. There are 3 sig figs in this number. The answer can only have 3 sig figs, so it has to stop here. We look at the next number. That rounds the 1 up to a 2. 2 sig figs. Here we have 1 significant figure, because we come in from the Pacific, go over the leading zeros. We have 4 significant figures. The answer can only have 1. So we have to round to 1. Leading zeros are losers. We have to round to there. So look at the 7, it rounds it up. Centimeters times centimeters is centimeters squared. All right, and so that's how those go, and you can practice a couple more. We'll have some in the video. Mixed operation problems are a little bit more difficult, so let's stop and look at a couple of these.
This video is going to show you how to simplify a compound expression involving adding, subtracting, multiplying, and dividing numbers according to the rules of significant figures. So here's the example problem. If I look at this problem, I'm going to use my order of operations in order to tackle it. That is, parentheses, exponents, multiplication, division, addition, and subtraction in that order. So I go through and I'll do all the math, and when I get my final answer, I get 456.5. I didn't round any numbers along the way. I kept every decimal in my calculator as I worked this entire problem, and that's my answer. Is just straight up answer as if it's in a math class. Now let's look at significant figures. So I'm going to re-examine the problem, keeping track of sig figs. 21.3. That's where I'm going to start because that's my exponent, and that's what PEMDAS says to do. Parentheses, exponents, multiplication, division, addition, subtraction. So exponents. 21.3, well that's 3 sig figs because it's multiplying. So I'm just going to keep track of the sig figs for this multiplication part of it. And when I get my final answer, I get 453.69. But 3 sig figs, that means 453, that's my sig fig. I keep the 69 mathematically, but I'm tracking sig figs now, so I'm going to put a line under the 3. The line under 3 is not a math operation, it's just me keeping track of where that last estimated sig fig is. Next step is going to be the multiplication and division. So that's going to be everything over here on the right-hand side.
All right. Notice there's 3 sig figs here, so he's just counting 1, 2, 3 sig figs. So because this is a multiplication problem, 21.3 times 21.3. So he's keeping track. He didn't get rid of all the other numbers. He just underlined it to know that this number should have 3 sig figs. And then the next thing in PEMDAS is to multiply and divide. Now again, assume all these numbers have units. So this is not a counting number. This has a unit of some sort. So he multiplies those all together. And this has 4 sig figs, 4 sig figs, and 2 sig figs.
So if I do this all in one step, since it's multiplied and divided, that's going to be 2 sig figs. So I have to keep track of 2 sig figs. So I do the calculation. And again, 2 sig figs, keeping track of the stuff on the right. So my final answer comes out to be 15.2 for everything that was on the right with 2 sig figs. So again, counted over 2 sig figs and underlined it. Even though I kept all my decimals, I'm tracking sig figs this time. So
now we went, notice we did multiplication here, and we did multiplication and division here. And now we can do the addition and subtraction. We have to change what rules we're looking at. Now we have to look at, instead of counting sig figs, look at precision. Notice this number is actually precise only to the ones place, because that's where it ended as far as sig figs goes. We put these extra numbers in and we round to the end. This number is precise to the hundreds, and this one is precise to the ones. So we're going to get an answer, and let's see what happens.
Now when I look at this, I'm adding and subtracting my numbers. So the rule is I round to the position where I have the greatest rounding. In other words, whichever estimated number is farthest to the left. Previously I told you to write all these vertically and just underline your estimated values. Whichever one's farthest to the left, that's where you round. For the sake of space on this presentation, I'm not going to do that. Instead, what I'm going to do is just do them all in a line, which is a little more difficult to keep track of. So this is the ones place, the 9 is in the hundreds place, and the 5 is in the ones place. So the ones place is farthest to the left. That means it's the biggest rounding error. So I'm going to round the 456.5 to the ones place, which, if I round it to the ones place, it's going to give me 456.
Okay, see? This number really, even though we put the 0.69 there, that was because we're not doing the rounding until the very end. We're pointing out that this number should end in the ones place. This number should end in the hundreds, and this one should end in the ones. So when we add them, it needs to end in the ones place, and so you round it to 456.
Now this is weird because there are rules for rounding with significant figures. So when rounding with significant figures, remember, if it's 457.5...
Okay, now we're not going to worry about this, because this is that exception about the 5, when it has a 0.5, and we're just going to always round up from a 0.5. So we're going to move forward now. Okay. All right, now let's go back to my example. So we did this. We did the Atlantic Pacific rule, and really the only other thing is you just have to be careful with the order of operation. So let's do and unit conversions. So let's do one more problem. Let me set it up and then we'll work it. All right, now this this problem, we're going to convert feet to centimeters, and that's an English to metric conversion, which I don't expect you to know. So I would give you this conversion. Well, this is just the relationship, and you have to turn this relationship into conversion factors. There's 2 of them. It could be 2.54 centimeters over 1 inch, or it could be 1 inch over 2.54 centimeters. Whichever one works. We're going to try to cancel units. So I'm going to change 42 feet, and I can't go straight from feet to centimeters, but I can go to inches. So I'm going to turn it into inches because inches has a relationship with centimeters. So 42 feet, I know that there are 12 inches in 1 foot. So the first thing is to cancel the numerator and the denominator, and that will give me 42 times 12, and the answer would be in inches at the moment. Right there, inches. But inches is not what I want. I want centimeters. So remember, you evaluate, make sure your answer. So now I have this relationship. I turn that into conversion factors, 2.54 over 1 centimeter, or 1 centimeter over 2.54. Which one? So let's just put 1 in. I'm going to put 1 inch over 2.54. Well, when I would look at this and say, wait a minute, my inches are not canceling. In fact, the unit here would have been inches times inches. That would have been inches square divided by centimeters, and that's not converting to centimeters. So this conversion factor is not the one I want. I've got it upside down. So I erase it and I put the correct one in so that I can get the correct unit. Always write your units. It's going to help you a lot. So now I put 2.54 centimeters over 1 inch. And now my units can cancel and I can do the math. So I'm going to pull my calculator up over here and turn it on and do the math. I have 42 times 12 times 2.54. And that gives me 1280.16, 1280.16, 1280.16. This is my raw answer with centimeters. Okay, raw. Now I have to evaluate for sig figs. My original measured value is 42 feet. That has 2 sig figs. These two things right here, these are definitions, and they're not going to determine your significant figures. The measured thing determines that, and that's 42 feet. So round 2 significant figures, I have to round to this spot. That would be 1300. I have to look at the 8. It causes me to round the 2 up to a 3. I don't just truncate it, I just don't knock it off. I have to put zeros where the 8 was and that 0 was. So this is 1300, not 13. And so centimeters is my unit, and that would be my final answer. If I wanted this in scientific notation, so this answer is perfectly fine unless I say, give me the answer in scientific notation. Well, then I got to move my decimal. It ends right here, so I'd move my decimal 1, 2, 3 places to the left. So it would be 1.3. I need to keep the 2 sig figs times 10 to the third. I moved my decimal places 1, 2, 3. If the number is the number above 1, yes. If the number is above 1, the exponent is positive. If the number is above 1, if the number is greater than 1, the exponent on the 10 is positive. So this would be my final answer in scientific notation. Okay? All right, just 1 second. We're going to do some more. All right, I erased the other, and I put up the mnemonic device to help you remember the prefixes. Gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk. Space space, micro space space, nano. Remember that the U stands for the base unit. The base unit, and the base unit has no prefixes. Okay? Then you're going to add prefixes. If it's this way, we're getting smaller. Our number is getting smaller, and if the other way, we're getting larger. Giga is a billion. A giga is a billion. So mega is million, so it's 10 to the 6th, and giga is billion, 10 to the 9. Every line represents another number. That would be 10 to the 8, 10 to the 7, 10 to the 6, 10 to the 5, 10 to the 4, 10 to the 3rd. This is kilo, and kilo means 1,000 or 10 to the 3rd power. See, if I put the decimal and I move it 1, 2, 3 places, that's 10 to the 3rd power. Hectodeci, unit, deca, unit, deci, centi, this is centi, we've used that one a lot. It means 100th, it's 10 to the minus 3. And then milli means 1,000th, it's 10 to the minus, oh, did I do that right? No, it's 10 to the minus 2. This is 10 to the minus 3. Okay, minus 4, minus 5. This is 10 to the minus 6. That's micro, and it has this funny little symbol right here. And nano. Nano 9 is 10 to the minus 9. Now, a nanometer is 1/1000th of a meter, so it takes 1 billion of them. See, 1 nanometer is 10 to the minus 9 meters, or 1/1000th of a meter. 1 nanometer is 1/1000th. 1, 2, 3, 4, 5, 6, 7, 8, 9 meters. Okay, so it takes 1 billion of them to make 1 meter. You've got to get the prefixes memorized. I'm going to make sure I add the prefixes on the on the Quizlet as well. Study them. You must know the prefixes by heart. Okay, and especially for unit conversions. So let's convert. Let's practice. We're going to convert 561.7 millimeters to, let's start off just converting it to kilometers. All right, so we're going to go from millimeters to kilometers. We're going to have to go through the base unit and then to kilometers. It's a two-step process, and you have to use bridge notation. So 561.7 millimeters. Okay, we're going to go to unit, the base unit first. So 1 meter and is 1,000 millimeters. Think of a meter stick. Pull up a meter stick. Every little tiny line is a millimeter, and it takes 1,000 of those tiny lines to make that meter stick. So that's the first conversion, and we cancel out millimeters. Now we're going to do the second conversion and turn from meters to kilometers. 1 kilometer is 1,000 meters. Then we cancel out the units again. And so the answer would be in kilometers, and we divide. And I'm going to pull up my calculator and show you how to do the division. Okay? So this is 561.7 divided by 1,000. That's the first division right here. And then divide again by 1,000 and hit enter. And that gives you the E. Notice that it says E negative 4. That means the exponent is a negative 4. So the answer would be 5.617 times 10 to the minus 4 kilometers. This first number has 4 sig figs. This number has 4 sig figs. It's a negative exponent because it's a very, very small number. And it's less than 1. So the exponent's negative. If I wanted to turn this number back into standard notation, I'd put a little arrow and move my decimal place that many spots. So I'll show you. 5.617. I'm going to move it 4 places. 1, 2, 3, 4 for the decimal, and then add the zeros. And so the standard notation would be 0.000561 kilometers. That's an okay answer. It's fine as long as I didn't ask you to put it in scientific notation. If I did, you need to do that conversion. Alright, now let's try this one. We are going to convert 42 gigagrams to nanograms. So here's giga, let's see, way over here. We're going to have to convert it. We're going to go through the base unit, and then from the base unit to nano. So it still is a two-step process. So 42 gigagrams. Okay, what's the relationship between a gigagram and the base unit? It's 10 to the 9. There are 10 to the 9 base units in 1 gigagram. A gigagram is humongous. So 1 gigagram, and that's a technical term right there, is 10 to the 9, or 1 billion grams. Okay? So now I can cancel. Gigagrams cancel out. And let's put it back in. Now we're going to go from grams to nanograms. A nanogram is a negative 9, so that means it takes 10 to the 9 nanograms in 1 gram. So there are 10 to the 9 nanograms in 1 gram. Okay? So we cancel it out. Grams and grams. And that's going to give us our final answer. Let's put this in the calculator as well. Make sure it's still on. So 42 times, and this time I'm going to use a scientific notation. I could do 10 up caret 9, and that's fine. Enter. That's the first one, and then do it again. Times again. 10 up caret 9. Enter. There's my answer. 4.2 times 10 to the positive 19. It's a very big number. 4.2 times 10 to the 19. It said E19. That's a positive. Nanograms. It's a huge number. Now, what if I want you to convert that into standard notation? Well, this means move your decimal 19 places. Since it's positive, you're going to move it to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 places. And you can see now why we don't use this standard notation, because the number of zeros that you have to put here is so big, it would be very easy for you to forget how many zeros you needed. So that would be 42 with all those zeros nanograms, and I don't even know what that is. And its numbers are so large. That's because nanograms are so small. If you need to look a video up on the size of nanograms or gigagrams, get the prefixes memorized. The last thing we're going to cover is percent error. Percent error, you'll be given the formula, and it's going to be theoretical minus experimental divided by theoretical times 100, or it could be percent error equals the actual minus the experimental divided by the actual times 100. In both cases, the answer is going to be a percent. So let's say that I'm measuring out, let's say that the theoretical value of my math, I'm not going to write out the whole word, okay? The theoretical value is 4.71 grams, and the actual value, or sorry, the experimental value, when I did the experiment, I got, let's say I even got 5.2 grams. So my theoretical, I should have gotten 4.17. I got 5.2. So we pick out the formula that we need, and we write the formula first. If you don't write the formula, you will lose a point. Okay? So it's theoretical minus experimental over theoretical times 100. That's writing the formula. You put no numbers in it. Then you put the numbers in. The theoretical value is 4.17 grams minus the experimental value divided by the theoretical value times 100. Now you still have to do PEMDAS. You're going to do the top part first. So you're going to simplify this portion. So 4.17 minus 5.2. So 4.17 minus 5.2. That gives me a negative 1.03. And we got to look at precision. So negative 1.03. This is subtracting. So I'm going to underline how precise. This number was only precise to the tenths place. This went to the hundredths, so I have to stop in the tenths. That's where my precision ends. So my answer up here really should only have two sig figs, this one and this one. But I'm not going to change anything until I get to the final math. Now I'm going to divide. So pull this back up. So negative, notice it still says negative 1.03. I'm going to divide it by 4.17. And that gives me negative 0.24700. Negative 0.24700. But its absolute value of that times 100. Now one thing else I need to cover is that the units here are grams, because it's grams minus grams going to give you grams. And that means the units are going to cancel, because grams divided by grams is nothing. The units for percent error is just percentage. Okay, now we have to multiply this number times 100, so move it over two places. So the answer is going to be 24.700%. Percentage is the unit. It's not negative because of the absolute value signs. Now, how many sig figs? Well, this number had 2 at the top, 2 sig figs. This one had 3, so this should really only have 2. 1, 2, so it's 25%. That would be your percent error right there, 25%. Notice again, up here, I did not change the significant figures. I left the raw number in, but I noticed that there's only 2 sig figs that should have been there because I'm subtracting. So 2 sig figs divided by 3 sig figs gives you 2 sig figs. Okay, that's going to be end of the video. You need to make sure that you use all the sites that are in the Prezzies for your studying purposes, and I hope you're ready to do well. I think you can. I'll see you soon.